Deep learning is a type of machine learning and artificial intelligence, AI, that imitates the way humans gain certain types of knowledge. Deep learning is an important element of data science, which includes statistics and predictive modeling. Types of deep learning. 1. Convolutional neural networks, CNNs. 2. Long short-term memory networks, LSTMs. 3. Recurrent neural networks, RNNs. 4. Generative adversarial networks, GANS. 5. Radial basis function networks, RBFNs. 6. Multi-layer perceptrons, MLPs. 7. Self-organizing maps, SOMs. 8. Deep belief networks, DBNs. 1. Convolutional neural networks, CNNs. Convolutions have been used for a long time, typically in image processing to blur and sharpen images, but also to perform other operations. For example, enhance edges and emboss, CNNs enforce a local connectivity pattern between neurons of adjacent layers. 2. Long short-term memory networks, LSTMs. Long short-term memory, LSTM, networks are a type of recurrent neural network capable of learning order dependence in sequence prediction problems. This is a behavior required in complex problem domains like machine translation, speech recognition, and more. LSTMs are a complex area of deep learning. 3. Recurrent neural networks, RNNs. Recurrent neural networks, RNN, are the state-of-the-art algorithm for sequential data and are used by Apple's Siri and Google's voice search. It is the first algorithm that remembers its input, due to an internal memory, which makes it perfectly suited for machine learning problems that involve sequential data. 4. Generative adversarial networks, GANS. Generative adversarial networks, GANS, are algorithmic architectures that use two neural networks, pitting one against the other, thus the adversarial, in order to generate new, synthetic instances of data that can pass for real data. They are used widely in image generation, video generation and voice generation. 5. Radial basis function networks, RBFNs. Radial basis function networks, RBFNs, are special cases of artificial neural networks. Biological systems are used as model for artificial neural networks in the way that artificial neural networks simulate the internal structure of the brain with its neurons and the interconnections between them.